Okay, so the last two sections we're looking at, 6.4 and 6.5, are getting away from 6.4. Actually, will go really fast, but that's going to kind of build us up to 6.5. 6.4 is matrix operations. And basically 6.4 is going to be all the basics that we need to get us ready to do what we've got to do in 6.5. Okay. And when we're talking about a matrix is basically just a bunch of numbers that's in some brackets, basically what it comes down to it. And what it's doing is it's taking, eventually we'll see one here in a little bit, where they're going to take a matrix and do something like this. And they're going to put a slash through it, so that basically they're going to take this thing and have it rewritten so that this is your equations over here, this is your equal sign, and this would be your values that you get over here. So we'll try to adjust a little bit. Keep getting. Okay, so this is what makes this. Actually, they're going to talk about this. I'll show you in a minute. But this is an augmented matrix where that they've kind of removed the numbers off of it, and everything that we're kind of going. Did we talk about that last time? Maybe. I think we did, didn't we? I think we did talk about augmented matrix. So, so we're going back and talking about all the parts and pieces on this one. When we're talking about these, whenever they talk about a matrix and they talk about this, they're always going to describe it by the number of rows and then the number of columns. So if we were talking about this matrix, you've got 2 rows going this way, and then you have 3 columns going up and down. So this would be a 2 by 3 matrix, that it's got 2 rows and 3 columns. So whenever they talk about a matrix or matrices is plural, when they talk about these, that it's always the rows first and it's always the columns second, so that you have a way that you can talk about the size of these. A couple of things that they'll mention with you, a couple of, they call, I guess, special matrix names. If you have 1 row, they call that a row matrix. If you have 1 column, of course, then that makes it a column matrix. And if you have the same number of rows and columns, or the same amount of rows and columns, they call that a square matrix. All right, now if it doesn't have any one of those other things, if it's like this one where it's a 2 by 3 matrix, it's not really any kind of special matrix, it's just a matrix. So that's 3 kind of, again, I don't know if you call them special, but just some names that they give to you if you have a certain amount of rows and columns when you go through these. Okay, so here's where we actually get into some of the operations on this. And it's really, as far as the adding and subtracting goes with matrices, it's really straightforward. That if you're adding or subtracting 2 matrices or 2 matrices together, you just add or subtract the values, whatever the signs may be that it tells you to do. that's in the same location. Yep. And that's it. There's not really anything that you really have to do. Now, the one thing that is true on this one that you have to kind of go through is that if you're going to add or subtract, the matrices must be the same size. So you can't take a 2x3 matrix and add that to a 1x4 matrix. So that's really the only catch that you have when you go through these. Okay, so let me show you a couple examples of adding and subtracting. And after we do that, we'll do a little bit of multiplication. So we'll take, for the matrix, we'll 1, 7, 2, -3, 3, -7. And we'll add that to 4, 2, -3, -5, and then -6, 7. Okay, so adding these together, just take it one piece at a time. So if you start in the top left, you're going to add that to the number that's in the top left. So that's 1 plus 4. That would be 5. Top right number, that's 7 plus 2. Now, and they didn't go into a lot of detail on this one, but when you talk about these, you're going to talk about the actual location-wise. This would be like if this was matrix A, they would say this would be like an A11, that it's the number that's in the first row in the first column. If they talked about this number, this would be A12, where they use like a lowercase a. So this would be in the first row, and this would be in the second column. So a lot of times you'll see that where they'll talk about like a subscript number, that this talks about the row location, and this is talking about the column location. They didn't talk about that really in this section, but that's, if you're going to describe locations, that's how you would describe the exact locations if you put them in that terms. But what we'll do now, we'll just stick with basically it's doing the same thing, just not talk about it here. So, all right, so in the second row, we've got 2 plus -3, -1, -3 plus -5 for -8, 3 plus -6 for -3, and then -7 plus 7 for 0. Okay, so addition, really nothing to it. Just add or, and depending on what the signs are, subtract the numbers that you have. It's in the same locations. Okay, the only one you have to be just a little bit careful of, and really it's more of just not getting in too big a hurry, is subtraction, because if you get in a little bit of a hurry, sometimes with the signs, you may throw a sign off a little bit. So the biggest thing with subtraction is just not to get in a hurry when you go through these. So go -2, 4, -8, 3, and minus 6, -2, -2, 5. Okay, now, and especially with subtraction, sometimes some people like to kind of write out their steps. If you do that, this is -2 minus 6. This would be 4 minus -2. This is -8 minus -2. And then 3 minus 5. Okay, so -2 minus 6 would be -8. 4 minus -2 is really 4 plus 2, so that would be 6. -8 minus negative 2 is really negative 8 plus 2, so that would be negative 6, and then 3 minus 5 would be negative 2. Okay, and that's it. There's with addition and subtraction, there's really not a whole lot to it that can really throw you off. Just take your time and don't get in too big a hurry when you go through these. All right, and then the last thing they talk about in section 4 is they talk about scalars. And this is where you just multiply. The numbers in a matrix are called elements. So you multiply the elements or the numbers in a matrix by a given value. And usually what they'll do in this case is they will give you some matrix. Maybe this is matrix A. All right, here's matrix A. We need you to find negative 5A. Well, that just means you take every single number here and you multiply it by negative 5. So negative 5A will just equal, well, negative 5 times 7 is negative 35. Negative 5 times negative 2 is 10. Negative 5 times 3 is negative 15. And negative 5 times 5 is negative 25. Okay. So pretty straightforward. They give you a number to multiply. You just multiply every single number in that matrix by the number that they give to you. Okay. Now, and this is where it kind of ties in with scalars. They talk about a little different option here, but they call it the additive inverse. And basically with the additive inverse, it's the same thing as multiplying by negative 1. That whenever you talk about the additive inverse where you multiply by negative 1, you're just changing the signs of all the numbers in the matrix. Yeah. So just a special little case that basically if you multiply by negative 1, they call that the additive inverse. That basically if you take some matrix you have, this one, and you multiplied it by negative 1, and then you added those two things together, you would wind up getting a zero matrix. That's really all that it's talking about when it talks about additive inverses here. Okay, and then the very last thing that they do with the scalars is they will have you solve an equation with some scalar multiplication mixed in with it. So they will tell you to solve for x when 2x equals 2a plus 3b. And then they'll tell you what the two matrices are. That a is 1, negative 2, 4, 3. And b is equal to 2, negative 1, 0, and 5. Okay, and really all you have to do is they give you the setup, so you go back and plug in everything that you can. So you got 2x, which we're going to solve for. And if you go ahead and do 2 times a, you double every single number that's in here. So that's 2, -4, 8, 6. I'm going to add that 2, multiplying every number in here by 3. That's 6, -3, 0, and 15. Okay, you got the addition sign here, so go ahead and put these two things together. So that's 2 plus 6 for 8, -4 plus -3 for -7, 8 plus 0 is still 8, and then 6 plus 15 is 21. All right, if that was x, we would be good to go. But because this is 2x, you still would solve this like a normal multiplication or division problem for this part. That if you have 2 times x, you're going to take everything in here and divide everything by 2, which means you're also going to take everything in here and divide it by 2. So when you do scalar multiplication, you can also do, technically you're doing scalar multiplication with this one because you're technically multiplying everything by half, which is the same thing as dividing it by 2. So you can do scalar multiplication, you can also do scalar division, or if it's multiplying by a fraction, it's kind of getting around that division part of it. So for this one, you would get that x would equal 4, just leave that as a fraction, -7/2, 4, and 21/2. Okay, and in 6.4, that is everything that they do. They do addition, subtraction, they do some multiplication with the scalars, and then they'll do a little bit of a solving equation like this, where that you're going to have to add or subtract some parts together, and then you basically wind up going back and either dividing by 2 or multiplying by 1/2, ever how you want to look at it to get through that part. Okay, and that's it. That's all that's in 6.4. Really straightforward, not a whole lot to it. They pretty much give everything that you need there just in that little bit of time. And really everything that's happening is they're building up to 6.5. That was 6.5. It's only got a couple of things in it, but it takes a little bit to kind of go through everything with this one because there's a lot of different steps and some different procedures that you have to kind of go through for 6.5. And 6.5 is matrix product and inverses. Okay, and the big thing with when you're doing matrices and you're working with solving these and going through the parts of them, with addition, you had to have everything the same size to be able to do add or subtract. When you start multiplying two different matrices, the first check you have to do basically is this: that to multiply matrices together, we'll just say it this way, that the columns of the first matrix must be the same as the rows of the second matrix. Okay, so let's say, and they're going to ask you that, let's say you've got a 4 by 1 matrix in a 1 by 2 matrix. It'll ask you, can you multiply these together? Okay, and really the easy thing about this one is that when you talk about the columns of the first and the rows of the second, basically it's the two inside numbers that you have here. If these two numbers are the same, I had a red pen somewhere. It's disappeared. That as long as these two numbers are the same, then yes, you can multiply these two things together. Okay, and then the size of the matrix you're going to have when you get finished is the other two numbers you have. So this is going to wind up being a 4 by 2 matrix. So the whatever two numbers you have left over that's here, that's going to tell you the size of the product. Okay, so that's basically what you're going to check when it comes down to these. So they'll give you, some cases they'll give you two matrices. Some of them they'll give you the size like this and ask you, can you multiply them together? Some of them they actually just give you the matrix and ask you, can you multiply? So then you got to go back and count the rows and columns. But put the two columns, put the two matrices together. As long as these two middle two numbers are the same, you can multiply the two matrices together. If they're different, if that had been a 4 by 1 matrix and that was a 4 by 2 matrix, then you wouldn't be able to multiply that together. Okay, so that's the one restriction that you have to have on the size, is that these two numbers in the middle have to be the same size to be able to multiply and get the products for these. The way it's going to work for multiplication is it's not scalar multiplication. This is where you're multiplying one matrix times another matrix. That it's a little bit more in depth than what you have to do for these. Basically is this: you're going to multiply the elements of the rows of the first matrix by the elements of the columns of the second matrix. Okay, so just like when you describe it, you describe it by rows and columns. Same thing when you multiply. You're going to multiply the rows of the first matrix by the columns of the second matrix. Okay, and when you do that, you're basically going to take the first number in the first row that's here, and you're going to multiply it by the first number that's in the column here. You're going to multiply those two numbers together. You would take the second number in the first row here, and you multiply it by the second number in the column here. If you have a third number in this row, you multiply it by the third number that's in the column of this one. So you're always going to match up the first number in this row and the first number in this column, and the second number in this row and the second number in this column, and multiply those two together. And once you do that, you're going to add all those numbers together, or subtract depending on the signs that you have. And what you're going to do then is you're going to add or subtract the products together to get the value of the new element of the new matrix. Okay, and it's just going to basically keep repeating on that one. You're always going to take, again, the rows of the first matrix, and you multiply that by the columns of the second matrix. Okay, so let's do this. Let's give you some examples of what we're going to do. Give you some different sizes, let you see some of those. And then after you feel like we're comfortable multiplying, then we're going to switch and do inverses, which is similar to what we were doing actually back on Tuesday with solving systems. It's similar to that, but not quite exactly that. So, all right, so here we go. Let's show you some parts of this one and see what we can come up with. All right, so let's take the matrix, which is 1, 2, 3, 4, and multiply it times -5, 3. Okay, and for multiplication, a lot of times they'll just have it like this. They might occasionally go back and put a dot in between that to show that's multiplication, but most of the time they'll just tell you to multiply. Usually they'll say perform the operation. If it's that case, they'll probably put a dot there. All right, so here's what we're going to do. Again, we're taking the rows of the first matrix. You're going to multiply that by the columns of the second matrix. So what we're going to do is we're going to take the first row and multiply it by the first column. So again, we're taking the first number and multiplying it times the first number that's here. So that's 1 times -5, and we're going to add that to 2 times 3. Okay, 1 times -5 is -5, 2 times 3 is 6. Put that together, and that's number 1. And since this was row 1 and column 1, that basically tells you where this answer is going to go. Now, if you need to kind of get the feel for this one, we know that this matrix is a 2 by 2 matrix. This matrix is a 2 by 1 matrix because there's 2 rows and 1 column. Okay, so the numbers do match in the middle. So the answer you're going to get from this one is going to be a 2 by 1 matrix. So it's going to look a lot like this. So this is going to be basically the first number that we have here. And then when we take the second row, and multiply it by the next column, that's going to get us the next answer we'll have here. So it's 3 -5. And then we're going to add that to 4 times 3. Okay, so it's -15 plus 12. So it would be -3, and that was row 2 and column 1. So basically the same thing on that one. That would put us there in the same spot. Okay, so that's kind of the system, the method that you want to go through, is that you're always going to take the rows that you have here, multiply it by the columns here, and again, you'll take the first number here times the first number here, second number here times the second number that's here, and then kind of go from there. All right, let's give you one that's a little bit bigger, a little different size, so you can see how it works if you've got something that's a different shape for it. All right, so for example 2, let's go with 2, 2, -1, and 5, 0, 1. And we'll multiply that by, let's go with 0, -1, 0, -3, 4, and just to have a different number out there, we'll put a 6. Okay, so again, if you check size-wise on these, we've got 2 rows here, so this is a 2 by 3 matrix. And this has got 1, 2, 3 rows and 2 columns, so this is a 3 by 2 matrix. So when we multiply these two together, the two middle numbers do match. This is going to wind up being a 2 by 2 matrix. Okay, so we're going to take it, again, one row at a time. So we're going to take the first row that we have here and multiply it by the first column that we have here. Okay, so then it's 2 times 0 plus 2 times -1 plus -1 times 0. 0 minus 2 plus 0, put all that together, that is -2. Oh, sorry. Okay, and again, this was row 1, column 1, so answer-wise, we're multiplying these two things together. Again, we said it's going to come out to be a 2 by 2 matrix. That would put this number in that first location here. Because whatever you're multiplying together, if you're multiplying row 1 by column 1, that answer is going to be in the first row and then the first column. Okay, so we multiplied those two together. So now we're going to take the first row again. We're going to basically, you take the first row that you have and you multiply all the columns that you have. So now we're going to take the first row that we have here and multiply it by the next set of columns that's here. So that's going to be, just kind of slide that down. I'm going to cover this part up so we can see it here. We're going to take 2, 2, -1, multiply it by -3, 4, and 6. So that's 2 times -3 plus 2 times 4 plus -1 times 6. Okay, so that's -6 plus 8 minus 6. That is 2 minus 6, so that is -4. Okay, and that was row 1 times column 2. So the same thing for this one. This is going to stay in the first row. We're going to go to the second column, and that's where that -4 would go. So if you keep up with what you're multiplying, which row times which column, this is going to tell you where this answer is going to go to kind of get to those numbers. All right, and then we'll do the same thing with the last row here. We have to take row 2 and multiply it by the first column and then the second column, and that'll get us the answers for the next set of numbers that we need there. So we've got 5, 0, 1. And we're going to multiply that by 0, -1, and 0. And this is row 2, column 1. So that is 5 times 0 plus 0 times -1 plus 1 times 0. Well, that's nice because everything comes out to be 0. So that number comes out to be 0. So again, that's row 2, column 1, so that put a 0 right here. And then last thing we'll do 5, 0, 1 times negative 3, 4, and 6. That's row 2, column 2. So that's 5 times negative 3 plus 0 times 4 plus 1 times 6. Now, if you're one of those people, too, that you kind of get maybe lose your spot as you multiply, if you do 5 times negative 3, you might actually go through and write down those two numbers. And if you do 0 times 4, write that down and then cross them off. And that way you always kind of keep things on track. Sometimes, especially if they're longer, if you get into like 4x4 matrix where you've got 4 numbers here and 4 numbers in the column, sometimes it can get easy to lose your spot. So if you kind of go through and just check them off as you work through, sometimes that'll keep things a little bit situated so that you don't lose your spot there. So negative 15 plus 6 would make that out to be negative 9. Okay, so that would be your final answer that we get there. So negative 2, negative 4, 0, and negative 9 for your 2x2 answer. Okay. So there's your steps for multiplication. That again, it's always some row in the first matrix by some column in the second matrix. And again, the elements there should be, if it's whenever you're multiplying these together, and that's why you have to kind of key on that these two middle numbers are the same. That as long as these middle numbers are the same, you'll have 3 numbers here and 3 numbers here, and you'll have a set of numbers you can multiply. If these numbers are different, then you don't have it so that everything matches up. So if these two numbers are different in the middle, then you cannot multiply them together. That's what it comes down to. Okay. Next thing they're going to talk about is what they call the identity matrix. And this is identity matrix and multiplication. That basically, for the identity matrix multiplication, it's easier just to kind of show you that it's whatever matrix you would have to multiply by to get the exact same matrix back that you were given. And and this works for square matrices. When you see this, it will never be in something that's a different size matrix. So kind of the big thing on this one is that when they talk about the identity matrix, it has to be a square matrix. It's got to be a 2x2 matrix or a 3x3 matrix. That basically you're going to have ones on this diagonal going from top left to bottom right. And if you do that, then it's always going to give you back the original matrix that you had. I think for what we're going to do, they could take it out to 4x4, but pretty much we're going to stick to either a 2x2 or 3x3. For everything problem-wise I've seen, that's about as big a matrix as that we'll work with. Okay, now here's where they're going to kind of add into the parts of this one. That if you take a matrix and you multiply a matrix by its inverse, so multiplying a matrix by its inverse will result in an identity matrix. Okay, so they're using the identity matrix that if it's just, combinations of ones and zeros, we've got ones on the diagonal. That if you take a matrix that you have, and if they ask you, and here's the next question they're going to ask you is, here's two matrices, are these two matrices inverses? That if you multiply a matrix by its inverse, you will always come back and get an identity matrix. And again, identity matrix is that if you took some original matrix and multiplied it by the identity matrix, you would get the original matrix back when you go through those. So here's the questions they're going to ask you. They're going to give you two matrices. And they're going to ask you, okay, are these matrices inverses? So we're going to have 5, 2, 3, -1, and we're going to do -1, 2, and then 3, -4. Now, one thing they may ask you to do, they may ask you to, a couple options they could do. They could say, are these matrices inverse? And it could be a yes/no question. They could ask you to multiply these two matrices together and then ask you, okay, is the product, or would these two matrices then be inverses? So they could word this one a couple of different ways. So you just have to kind of play around with it and ask. Sometimes they may ask you to find the product first and then tell if that product would result in these two matrices being inverses. So they could word it a couple of different ways when they go through these different problems. Okay, so anyway, we're going to multiply these two things together and see what we can come up with. All right, so we're going to take row 1. Multiply it by column 1. So we're going to take 5, 2, and multiply it by -1, 3. So that's 5 times -1 for -5. Add that to 2 times 3, which is 6. So those two together are 1. Okay, so far so good. That this one came out. And again, if that came out to be something other than 1, then you know that we're done. So for this to work out for the next part, we need this to be a 0. So we're going to have to take the next row we have here, multiply it by the next column. So we're going to take 5, 2, and multiply it by 2, -4. And 5 times 2 is 10. 2 times -4 is -8. 10 minus 8 is 2. So already we can go ahead and answer this one. Are the matrices inverses? No. Now, and again, some of these they may ask for the product anyway. They may ask you to go ahead and find it and answer the question. So sometimes this may be the second question. So they may say find the product, and then they may ask you, are these two matrices inverse matrices? Then your answer would be no. So they could, again, answer it a couple of different ways. And we'll go ahead and finish this out to get the actual full product that we have here. So this was row 1 times column 1, row 2 times, row 1 times column 2. And over here, let's do row 2. So now we're going to do 3, -1, and multiply by -1, 3. So that is -3 plus -3, which would be -6. So then we'll do that times 2, -4. So that is 6 plus 4, which would be 10. Okay, so, but again, there's your product that you have. And again, for it to be a matrix, for it to be inverses, you'd have to have 1 and 1 and 0 and 0, and obviously that's not anywhere close. So main question is, are the matrices inverses? No. But this would be the product that if you did A times, if this was matrix A and this was matrix B, this would be A times B. So, and again, that's one of those questions where they can word it all kinds of different ways when it comes off of this. All right, let's give you one more that's a little bit bigger matrix. We'll give it a 3 by 3 to kind of see what that would look like. So that's example 1. And this would be example 2. Okay, so there's the next two matrices, and we're going to multiply these together and see if we get a identity matrix. So same question, they're going to ask, are these two matrices inverses? Okay, 3 by 3, so a little bit more work on this one, so just have to be a little bit careful as we're going through these. Okay, so starting with row 1, good news is it's all 1, so when we do row 1 times these, it's going to be 1 times 1.5, which is going to be 1.5, negative 1, and then 0.5, and we're going to add all that together. Well, 1.5 minus 1 is 0.5, 0.5, and 0.5 is 1. So that one works out well. Okay, then we're going to take one, and again, with this being all ones, it makes this part of multiplication really easy, that we're just going to take these numbers and just add those numbers together. So it's 0.50 and negative 0.5, put all that together and it's 0. And then the last one, same thing, we're just going to put all these numbers together. See what happens. It's negative 1.5 minus 1, that's a negative 0.5 plus a positive 0.5, that would be 0. Okay, now the rest of them won't be that easy, but this one, because this was all ones, we're not changing anything at all, so we just get to add these numbers in the columns as we go along. So this was everything multiplied by row 1. For row 2, and just try to save some space, we're going to do 2 times 1.5, which would be 3. We're going to do 3 times negative 1, which would be negative 3, and 0 times anything is 0, so we add all that together, and that is 0. Okay, so here's where we did column 1, column 2, column 3. So now we're going to take row 2 and multiply it by column 2, so it's 2 times 0.5, which is 1, 3 times 0, which is 0, and 0 times 0.5 is 0. Add all that together, and that one comes out to be 1. And then for the last column, we're going to do 2 times negative 1.5, which is negative 3. 3 times 1 is 3, and 0 times 0.5 is 0. Add all that together, and that comes out to be 0. All right, and then just so we can kind of get it here, we're going to do row 3, do it the same way. So it is 1 times 1.5, 2 times negative 1, and then 1 times 0.5. So 1.5 plus 0.5 is 2. 2 minus 2 is 0. So that's everything in row 3 to start with. All right, for column 2, it's 1 times 0.5, which is 0.5. It's 2 times 0, which is 0. And then 1 times negative 0.5, which is negative 0.5. Put that together, that's also 0. So it looks like we're on track to get the identity matrix. So as long as this last one checks, we're good. 1 times negative 1.5 is negative 1.5. 2 times 1 is 2. And 1 times 0.5 is 0.5. Should have screwed this over. And that 2.0. So we've got negative 1.5. This is 2.5. That would come out to be 1. So then we get 1 for that last digit there. Okay, so they ask, is this an identity matrix? Yes, it is. So that means that these two things would be inverses of each other. Okay, so if they give you two matrices and ask if they're inverses, just multiply them together. And as long as you get ones on the diagonal and everything else is zeros, they are identity matrix, or they are inverses. If you get any other number than that, then they're not going to be inverses. So it's just an extension of doing multiplication, really is what it is. Okay, and then the last thing they're going to ask you to do in 6.5 is, instead of giving you two matrices and asking if the two matrices are inverses, they're going to give you a matrix and ask for you to find the inverse. Okay, so if you're given a matrix A, the inverse of matrix A, what's that comma here, is shown by a negative 1. So whatever matrix they give to you, and with the matrices, they're going to label those with letters. So it's matrix A or matrix B or matrix C or D. To show that it's the inverse, you're just going to use that same letter and then just put a negative 1 in the exponent. And that's going to show you that that's the inverse of it there. Okay. Now, there is a little bit of a shortcut you can do for a 2 by 2 matrix to find one, because there is a possibility of some matrices not having inverses. There's a shortcut for a 2 by 2 that they'll give to you. Now, 3 by 3s, because there's a lot more work to getting a 3 by 3 matrix, they don't, from what I could see, they don't do any of these with 3 by 3 matrices that you're not able to find the inverse of it, because there's a lot more work to kind of go through these. So let me show you a shortcut. This, and again, this works on a 2 by 2 matrix. You don't have to worry about checking the 3 by 3s, because they should all have inverses, because there's a lot more steps and a lot more work to get through those. So this is a check for a 2 by 2 matrix. And there's different ways that you can do these. This is just one little thing it's an easy check for a 2 by 2 matrix. Okay, so basically here's what we're going to say. Now, and again, you can find determinant of 3 by 3 matrices, but every problem that I saw when I was doing this one, they only had you worry about doing this on a 2 by 2. So this is kind of a shortcut to kind of get you there for this one. Because on the 2 by 2s, they'll give you some and say, all right, can you find the matrix if possible? So they'll have an option where you can go back and fill in the matrices of the inverse that's there, and then they'll give you a part B where it's not possible, and you do, when you click on that one. This is something that you can do for the 2x2s. It's a really quick, really easy check to see if you can actually find the determinant or not. Okay, and determinant, a lot of times they'll say for short it's just DET. So let me give you this one. So let's say matrix A is 2, -3, and then 2, -4. So to find the determinant of A, here's basically what you do. You take the matrix that you have, and you basically do cross multiplication, but you're going to multiply you're going to multiply up. So you're going to go this way. So you're going to do 2 times -4, which would be -8. And then 2 times -3, which would be -6, and you're going to subtract those two numbers. So it's -8 minus -6, which is -8 plus 6, which is -2. So basically, you do cross products, but the difference is with cross products, to make it work out, you have to go up. So you're multiplying 2 times -3 and then -4 times 2, and then you put a minus in between those two numbers. Okay, and if the determinant is equal to 0, then it doesn't have an inverse. If determinant is anything other than 0, then it does. So you can be the optimist or you can be the pessimist here, because they basically say the same thing. So if determinant does not equal 0, then we'll say it has an inverse. So if determinant equals 0, there is no inverse. If determinant does not equal 0, then it has an inverse, then you can go back and find. So this would be a question that if you want to do a quick check on this one before you actually went through and found all the steps on this one, at least this one you would know, all right, it does have an inverse because I've got -2, so I can find the inverse of this one, then I would go find it. So for a 2x2, this is just a really quick, easy check, so you can answer a question either yes or no. And then if the answer is yes, then we'll go ahead and actually find out what the inverse would be. Okay, so to find the inverse, we've got a few little steps we have to go through. So you're going to write a matrix on the left. And then you're going to write the identity matrix on the right side with a slash in between the two. So write the matrix on the left, the identity matrix on the right. With a vertical line between the two. Okay, so then basically after you've got that, you've got the original matrix you've got an identity matrix that is basically setting those two things to it. You're going to basically do operations, kind of like we were doing last time with systems of equations. But this one's with matrices, you're going to make it so that now you're going to basically do equation operation that you have to change the left-hand side to be the identity matrix. And then the right-hand side just kind of follows suit, and whatever happens, happens on that one. So we're going to use equation operations to write the left side as the identity matrix. The right side will be the inverse. Okay. So we'll start with a 2x2 matrix and show you what that would be. We'll show you a 3x3 matrix, and then that's really the only two options that they'll give to you. It's either 2x2 or 3x3. They do not give you a 4x4 because that would take it would be the same steps. It would just take a little while to kind of get there. All right, so here we go. So we're going to say find the inverse of two negative 3 and 2 negative 4. Okay, because we just checked that same matrix earlier to know that it did have an inverse. So back here we did this. We used that to find the determinant, and we found out that the determinant wasn't equal to 0, so we knew we could find the inverse of it. So now we've got this same one. Let's go ahead and find out what the inverse would actually be. All right, so what we're going to do is we're going to take this matrix that we have, and then we're going to write the identity matrix over here. All right, and what we've got to do is we've got to take this left-hand side and rewrite it so that it looks like this. So we're going to have to do, all the operations we can do on this thing to get it down to the point of where we can do that. All right, so the very first thing I'm thinking is, let's take row 1, and we're going to multiply it by -1, and we're going to add that to row 2. That way we'll get 0 in the bottom down here. So we've got -2, 3, and everything on the right-hand side, we're going to do the exact same thing. We're going to multiply everything here by -1. So basically it would be that. We're going to add that to row 2. So we get 0, -1, -1, 1. Okay, so first row is going to stay the same for now. And we added, basically just multiply this by -1, so now we've got a 0 in this location. So now we have 0, -1, -1, and 1. Okay, to get a 1 in the top right here, really easy. Let's just take this whole thing and divide it by 2. So that's going to be 1. Now it's going to be a fraction, so hopefully that doesn't throw anybody off too bad. It's going to be 1/2, 0, and then the bottom's going to stay the same. Now actually on the bottom one, you want this to be a positive 1, so let's go ahead and multiply this thing, or we can divide this thing through by -1. So that we do that, that'll change that from a -1 to a positive 1. So we'll change that sign, and we'll change that sign. Okay, so again, first thing we did was I just said, all right, let's multiply -1 times this, add these two together, and that'll make a new matrix here that's got 0 in this corner. We want this to be a 1, so we divided by 2 to get that to a 1. We need this one also to be a 1, so we multiplied or divided by -1 to basically just change the signs. And then the last thing we've got to do now is we need to make this number a 0. So now we're going to take row 2, multiply it by 3/2, and we're going to add that to row 1. And that'll give us the new equation that we're going to have up here. So multiplying by 3/2, that's going to make that to 0. So we're going to take the original row that we had here for row 1. And we said we're going to multiply everything here by 3/2. So that when we add that together, that'll make that be a 0. All right, so that's going to be 3/2. That's going to be -3/2. So that's 1, 0. That's a half plus 3/2. That's 4/2. That's 2. And then that's -3/2. All right, and that will be the new row 1 that we'll have that will go here. So that was 1, 0, 2, -3/2. And then the bottom row is good, just like it was. Okay, so then your inverse is this right-hand side over here. So it's 2, -3/2, 1, -1. Okay, so there's, again, what you're doing is you're trying to take the original matrix that you have, and we're rewriting it so that you've got it set equal basically to the right hand side is identity matrix. We're going to flip everything around so that the left side becomes identity matrix, and then whatever the right side is, that's going to be the inverse that you would have there. Okay. Now let me give you one more of those, and then we'll do a 3x3. Okay, and again, all the 2x2s, they will tell you to find the inverse if it's possible. And some it won't be possible, so instead of doing all the work to kind of get there, this is a quick, short, easy way to know if something's possible. All right, so again, easiest way to check it is multiply 10 times -3. Leave enough room there. Didn't leave enough room to show my work. So 10 times -3 is -30, minus 6 times -5 is -30. So it's -30 plus 30, which equals 0. And if it's 0, then it's not possible. Okay, so to me, that's the quickest, fastest, easiest way to be able to check. They give you another option on how to do that, and it works. But to me, this is just the fastest way to be able to check to see if something's possible or not. All right, let's give you one more 2x2. and then we'll finish off with a 3 by 3. All right, and again, if you did a quick check on this one, you've got 4 minus 6, which would be -2. So that case, it checks out. So this one does have an inverse. So, again, it's a quick, easy check with a 2 by 2. That equals -2, so then we're good to go. It does have an inverse. All right, so to find the inverse, take the original matrix we have, let's set it equal to the right-hand side, and then we go from there. Okay, so got kind of a good bonus on this one. The top left corner here is already 1, so that one's good. We just need to make this bottom left-hand corner equal to 0. So let's take the top equation, or top row here. Let's take top row times -3, and then we're going to add that to row 2. We're going to get it in right here. So it's -3, -6, -3, 0. We're going to add that to 3, 4, 0, 1. So -3 plus 3 is 0. -6 plus 4 is -2. -3 plus 0 is -3, and 0 plus 1 is 1. Okay, so just rewriting that one where we've now taken that bottom row and made it so that this bottom left-hand corner is 0, we're good to go here. Now, you've got 2 options, and I'll be honest with you, here's where we need to make this out to be a 1, we need to make this out to be a 0. Since these 2 numbers are already opposite signs, before I go back and make this a 1, I'm going to go ahead and just add these 2 things together so that I can make this a 0 here. So let's take row 1 and add it to row 2. And that'll give us a new row 1. Okay, if we just add those 2 things together, that's 1, that's 0. 1 minus 3 is -2, 0 plus 1 is 1. Now we've got the top row just like it needs to be. Now it's 1, 0, 2, -1. All right, now we can worry about this one, making this out to be a -1. So all we've got to do now is just divide this one by -2, and that way that'll make that a +1 that's here. So that's 1, 0, -2, 1. Divide everything by -2 here, that's a 1. Negative by negative is a positive 3 over 2, and make that a -1/2. Okay, so your inverse would be -2, 1, 3 over 2, and -1/2. Okay, and then the last one we'll do is we'll do a 3 by 3 matrix. And again, with all the 3 by 3s, they shouldn't ask you, for examples, all the examples I looked at, they all turned out to be inverses. They should all be possible. Because if not, it's a lot of just, you do a lot of work to find out that there's not an answer that's possible. So this one, all the answers, all the questions that I saw that were picked, you could find the inverse. Okay, so there's the original matrix. And there's where we're going to set it equal to the identity matrix. Okay, so we've got to make, this one's already 0, so we're good there. We've got to make this a 0. We've got to make this a 1. This is 0, 0, 0. Make this a 1. So we've got to, again, make it so we've got just ones on the diagonals, and we're going to get rid of everything else. To me, the easiest thing is to make this work out to be 0 here. We're just going to add these two together. So we're going to do row 1 plus row 2, and that'll give us a new row 2. So we make that a 0. So that's going to be 1, negative 1, 0, 1, 0, 0. We're going to add that to negative 1, 2, 3, 0, 1, 0. So it's going to be 0, 1, 3, 1, 1, 0. Okay, now, and to make it 0 here, we're going to go ahead and just kind of do two steps here at the same time. Let's do row 1 plus, sorry, let's do row 2 plus row 3 here to get a new row 3. Because this is already a negative 1, so if we add negative 1 and 1, that'll make that out to be 0. So that'd been easy. Go for that one. Sorry, didn't have that pulled down far enough. Okay, so we're adding these two together to get a new row 2. Now we're going to add these two together to get a new row 3. Makes 0, 2, 5, 0, 1, 1. Okay, so here's our new row 2. Here's our new row 3. We're going to put those two together with the original row 1 we had here. So that was 1, negative 1, 0, 1, 0, 0. This was the new row 2. 0. And this was the new row 3. Okay, so rewriting all the rows together, again, we left the first row the same. Here's our new row 2, and then here's our new row 3 that we've got put together. Okay, so now we've got to make this a 0, we've got to make this a 0, and we've got to make this a 1. To make this a 0, this is really easy right here. So let's take row 1, add it to row 2, and that'll give us a new row 1, because that'll make that a 0 here. And that way we don't have to multiply anything, or we don't have to divide anything. We can just add those two things together to get what we need. So that's 1. No, hang on. We don't want to do that. Sorry, because then that's going to make that it's going to help out, but then that's going to make that a 3. So then that's not going to help anything else. So we're kind of shooting ourselves in the foot. Now, if you want to go ahead, if you do that, if you start doing that, and then you realize, oh, well, that's not going to help because now I made that a 0, but then I changed that number, you can just kind of scratch that out. So I wasn't paying attention there. And that's okay. Sometimes you'll do that and you just kind of say, oh, well, that didn't help me any because I just changed up which ones we had. All right, so what we're going to have to do then is let's get this one down to a 0. And then once we get this down to a 0, then we can multiply this number times this to eliminate this one, and then we can go back and kind of go from there. So this is where Um, when it talked about getting stuff in row echelon form, that's where you want to help. That you want to get all the zeros here first, and then once we've got all the zeros here, then we can kind of move our way back up to go from there. So we're going to take row 2, multiply it by -2, and we're going to add that to row 3. So multiply everything here by -2. That is 0, -2, -6, -2, -2, 0. I'm going to add that to row 3. Okay, so that is 0, 0, -1, -2, -1, 1. All right, again, that would be our new row 3 because now we'll have the 2 zeros here. And since we're really close here, let's go ahead and take this equation we got here, this row, and let's go ahead and just change it and multiply it by -1 because this is -1. We need to make it a +1. So we'll kind of do 2 steps at the same time here. That we'll take this new row 3 we have, we're going to multiply it by -1 so we can make that out to be a 1. That's going to be 1, -1, 0, 1, 0, 0, 0, 1, 3, 1, 1, 0. And then multiply everything by -1. That's 2, 1, -1. Okay, so first thing you're really trying to do is you're trying to make this out to be a 0 and then make both of these out to be zeros. And then we can start working our way back up to make sure that we don't do like we did here and just wind up just swapping things out. So as you're going through these, that's really what you're trying to do is make it so this bottom left-hand corner is all zeros, and then we can easily work our way back up for this one. Now we can take row 3, multiply it by -3, and add that to row 2. And that'll give us a new row 2. So everything in here times -3. So that's going to be 0, 0, -3, -6, -3, +3. And then we're going to add that to everything here. Okay, so 0, 1, 0, -5, -2, 3. Zero, 1, 0, -5, -2, 3, and then this row stayed the same, 0, 0, 1, 2, 1, -1. Okay, and then now we can go back and do like we were trying to do back up here and messed up. Now we can just add these 2 rows together, and then that will knock this back to 0, and then we should be good to go. Okay, so now we're going to take row 1, add that to row 2, and that'll give us a new row 1 where we have zeros all the way across there. So it's 1, 0, 0, -4, -2, and 3. All right, and that should be our final answer we get here because now we've got this in row 1. And this for row 2. And that was row 3. Oh, sorry. Okay, so when it asks for the inverse, basically now we can just kind of circle that part and know that that's what the inverse would be. Okay, and again, with the 3x3s, from what I can tell, they make it so that all of them have inverses because the book tells you the check you can do to get that point, but it's a little bit more tedious than what we're doing for the other one. And finding the determinant of a 3x3 matrix is a little bit longer step and setup to get to it. So we're not going to worry about that one. This one, they should all pretty much have an inverse. You can kind of, if you want to scan through some examples, it'll show you, how to go back and what to do. But everything that I saw, you always have an inverse for the 3x3 just because you do a lot of work, and it would be a little bit on the cruel side to make you do all that work and then not have an answer that's going to be there. But anyway, all right. Well, that is everything that I have for us today.